Hey guys, welcome to Alco Forces. So today we will be continuing with Leetcode problem number 403, that is a frog jump. So this is very interesting problem. So what I'll do is I'll just go through the code problems description once, and I'll explain you the problem side by side. Then I'll explain you the solution, and then we can quickly do a dry run as well as we'll move to the coding part. Okay. So let's begin. So it says that a frog is crossing the river. A river is divided into some number of units, and at each unit there may or may not exist a stone. Then it says that the frog can jump on a stone, but it must not jump into the water. Now we have been given a list of stone positions in sorted ascending order. This is a very important part which you need to remember. Then it says that determine if a frog can cross the river by landing on the last stone. Initially, the frog is on first stone and assume the first jump must be 1 unit. Okay. So, and if the frog last jump was k units, its next jump must be k minus 1, k or k plus 1 units. The frog can only jump in the forward direction. Okay, so let me just explain you. So let's say this is a whole river. Maybe you can consider this a whole river. Okay, now these are the stones, that is 0, 1, 3, 5, 6, 8, 12, and 17. So these are various stone positions in the river, right? So let's say the frog initially is at position 0, that is the first stone. Okay. So now where it can jump? So it can jump only 1 unit. Like it is said, it is mentioned that the first jump must be 1 unit. Okay. So we have to make the frog jump such that we are reaching to the end of the river. That is, we are reaching here. That is the end of array in our case. Okay. So let's say the frog is at I I'll show you in this way. So let's say the frog is at 0 position initially. So how many jumps, or maybe in what combination of jumps are possible from 0 unit? So let's say the frog can jump only 1 unit, right? As it is mentioned. So he jumps 1 unit. Okay. So now how many jumps he can take? Let's say now he is at position he's at position 1. Okay, that is the first stone. Now how, okay, here the K will be, let's say the K is 1 because he has jumped 1 unit. Now how many okay, I'll write it this way. So now how many jumps are possible from k equals to 1? So we have been given in the problem that now either k minus 1, k or k plus 1 jumps are possible. Okay, so he can jump, let's say here k equals to 1, so he can jump 0 unit, 1 unit, or 2 units, right? This is k minus 1, k or k plus 1. So from 1, he can, let's say, if he jumps, if he jumps 0 unit, then let's see what happens. So from here, it jumps 0 unit. So now the next position will be 1 plus 0, right? 1 plus 0, because it is mentioned in the problem that his next position, his next jump must be either k minus 1, k or k plus 1 unit. So if it is k minus 1 units, so at what position he will be? So he will be at the current position plus the jump he has taken. So here it will be at one position only, right? So is he moving ahead? No, he is not moving ahead. So we cannot take 0 jumps here. So we will take one jump, let's say. So what it is? 1 plus 1, 2. That is, he should be at position 2. But is there position 2 here? No, right? So he cannot take the first jump either. So we are left with only one option, that is 2. So let's say instead of 1, I am going with 2 jumps. So is second, is 2 jumps possible? Yes, because if he takes 2 jumps, then he will be moving at position 2, position 2, sorry, position 3, that is stone 2. Okay, so from let's say I'll write it this way. He takes 0 jumps, and the the position I will just write it here. So instead of 0, it should be it should be 1. Okay. So from 1, if he takes 0, so this is not possible. Now he takes 1, so this is also not possible because he will be at position 2 in that case, and it is not in the given array. So now he takes 2 jumps, and the position will be 1 plus 2, that is 3. Okay. So now he is at this second stone, that is third position. Now let's say he is at 3. Okay. He is at third position. Now how many? Okay. Now the stones are okay. Now the number of jumps are either 1, 2 minus 1, that is 1, or 2, or 3, right? Because we had made the previous jump as 2, so now he can take 2 minus 1, 2, or 2 plus 1 jumps, right? Okay, so is one jump possible here? No, right? Because 3 plus 1 equals to 4. It is not present. That position stone is not possible. Can he take 2 jumps? 3 plus 2, 5. Yes, it is there in the list. So he can take from here, he can take 2 jumps, and it will land him at the position 5. Okay. Okay. So after 5, let's say he is at position 5. So after 5, and he had taken 2 jumps, right? So again there are 3 jumps possible, that is again 1, 2, and 3. So I'll take it like this. Is one jump possible? Yes, because 6 is present. So I will make 5 plus 1, that is 6. Okay. Now is 2 jumps possible? 5 plus 2, that is 7. Is 7 present? No, it is not present, right? Okay. So is 3 jumps possible? 5 plus 3, 8. Yes, it is possible. So we can also take 3 jumps. Okay. And now if I am on 8, so okay, if I am on 8, then how many jumps are possible? Either 2, or either 2 or 3. See, on 8 he had previously made 3 jumps, right? So either 3 minus 1, that is 2, or 3, or 4 jumps are possible, right? 2, 3, or 4 jumps are possible. So from 8, can I take 2 jumps? No, because 11 is not present. Can I take 3 jumps? Sorry, 10 is not possible. That's why he cannot take 2 jumps. Can he take 3 jumps? No, he cannot take 3 jumps as well, because 11 is also not possible. Can he take 4 jumps? Yes, because 12 is present. So he takes 4 jumps, and he ends up into 12. Okay, so let's say now the current index is 12. He had taken 4 jumps, so now he can take 3, 4, or 5 jumps, right? Okay, so I am on 12. Can I take 3 jumps? No, because 15 is not there in the list. Can I take 4 jumps? No, as well, because 16 is also not present. Can I take 5 jumps? Yes, because 17 is present, and we can see that 17 is the end of the river, right? That is the end of the list. So this path, this whole path is one possible solution. Now let's explore other solutions as well to determine if they are possible or not. Okay, so from 5, we have explored 1 and 3 jumps. From 8, we had explored okay, so we will go back to 5. Okay. For six, now let's start exploring from 6. Okay. So we have explored one jump. Now let's explore uh, two jumps. Okay, because the previous jump was one, so we can explore two jumps or one jump or three jumps. Okay, from 6 is one jump possible? No, it is not possible because 7 is not present. Is two jumps possible? Yes, it is possible. Okay, so it will end up on uh, 8. Okay, so my next position is 8. And again here 1, 2 and 3 jumps are possible because the previous position was 2. Now from 8 is one jump possible? No. 9 is not there. Is 2 jumps possible? No. 10 is also not there. Is 3 jumps possible? No, because 11 is not also not there. So this path will lead him to nowhere. Okay. Okay, so just see if any other path is possible. From here we have taken second jump. From here we have taken, like, it is three jumps, right? And we have explored all the jumps less than or equal to this three. And here also we have taken all the jumps less than or equal to four, right? So this is the only path which can lead him to destination. And yes, he can reach to the end of the river, right? So it will return true. Okay, so I hope you are getting this solution. So we have also completed the dry run here, and so basically, how we will approach this solution is basically what we can do is here we will first of all explore the all possibilities, right? And as we have seen in the problem, so for each of the jump, let's say I am on 5. Okay, I am on maybe let's say 5, and previously I had made two jumps. So now what we are doing is we are checking if 5 plus 2 jumps is 5 plus 2 jumps present after this particular 5, that is on the right side of 5. Is 3 is 3 jumps are is 5 plus 3, that is 8. Eighth position is there. So yes, it is there, right? So we will move to the to that jump. So if you are able to observe that we are basically doing search, like that is for each position and for each jump, we will be basically doing the search in the right side of the current position. We will be checking if the position plus the jump we are taking, if it is present on the right side or not. If it is present, then that yes, that particular jump is allowed. But if it is not possible, then we will drop that jump, right? We will be not moving ahead from that jump. So if you are getting it, that basically we are exploring all the possibilities by having this tree. And for each of the node of this tree, we will be doing binary search, right? And it might happen that see here, we are given certain constraints. We are given uh, around stone length is 2000, right? So it will, like, this solution, how much time complexity it will have? So it will have, basically we are traversing all the possible solutions, right? So it might lead us, it is a brute force solution, so it might lead us to time limit exceeded kind of error, right? So, because we are traversing around 2 raised to n possibilities, and that will be the time complexity of this solution. So, it is very large, right? So, how we will try to optimize it? So, basically, we can use a cache because as you are observing, so for 5, right? If it is see here for 6 also it ends up on 8, and for 5 also it ends up on 8. So we have to repeat, we have to check that from 8 is it possible to reach to the end of array. Similarly here we are seeing from 8 is it possible to reach the end of the array, but we also have to keep the previous jump in mind. So is it possible that we create a cache which has the solution of the current position, the previous jump, and the result? It is it possible? Yes, because it can save us a lot of computation. So it will optimize this for sure, right? So that is why we will be going ahead with the exploring the number of solutions plus binary search, plus we will be using memoization also here. Okay. Okay, so so I have already coded up the solution. I can also restart. We can also restart the solution once. Okay. So what we can do is, basically, if you notice, we are doing a DFS traversal here. Okay, so we are doing a DFS traversal. What it wants us to return is Boolean, and we will be doing some DFS, I mean, not exactly DFS. We can call it DFS as well. Okay, so I'll just make it DFS. So let's give more meaningful name. So I'll just name it can reach. It will have a stones array for sure. It will also have one variable of current position. It will also have previous jump. Okay, and this will return me true or false as required in the problem. So I will just return can reach stones. Current position is 0 because he has not taken up any jump yet, and that is why the previous jump will be 0. Okay, so now let's see what he has to do. So let's see, he is at position 0. So firstly, he has to okay, so let's say he is at position k. So as given in the problem, he can either take k minus 1 k or k plus 1 units of jumps, right? So let's say in next jump equals to okay, so I am at previous jump, that is let's say previous jump. Let me make it k so that it would be more intuitive to you guys. Okay, so my current position is position. So I'll just make it next position equals to pos plus k minus 1. Okay, so this is the one of the possibility which he can do. So what now, as we had seen in the explanation, so what I'll do is I will do a search. I will do a binary search, and this will return to me the position. It will check whether that position, next position, is allowed or not, and if it is allowed, then it will return me the index of that particular stone, right? So I'll just have stones here, target post. This will be the value which we want to search, low and high. Okay. So I will write the method for having the binary search. I hope you are aware with the binary search method. So if low greater than high, then we will return minus 1 to indicate that this jump is not possible. Okay, and as there is index from 0 to 0 to stones dot length, so minus 1 is indicating that the particular position is not possible. Okay, now our favorite part, that is if target pose is equals to stones of mid, then I will return mid. Else if target pose greater than stones of mid, if it is less than, okay, so that is the target position is, let's say, 1, but the mid is at here. Okay, so what we will do is now we will search from 1 to 6. Okay, so I will return search stones low mid minus 1, else I will return search stones mid plus 1 and high. Okay, so that is if my current position is at 12 and if the mid is 6, then I have to search from mid plus 1 to high, so as that I can find 12. So if you have any confusion in this binary search, then you can maybe look that first, and then you can come to this solution, so that it would be more understandable to you. Okay, so now what we'll do is I will search basically that stones. Target pose will be next pose. So we are searching if the next position is possible or not. That is, if the next stone on which we are jumping, is it even there in the stones array or not. Okay. My low will be position plus 1. That is, if I am on the position 0, so I will be searching in the right side of the current position. Okay. And the and high will be stones dot length minus 1. Okay, now this will return me some index. Okay, so now what we'll do is, if index greater than 0, and and uh and okay, if index is greater than 0, and then what we can do is, if index is greater than 0, then we can understand that yes, that position is possible. And we also have to check one thing. So if he is at this position, and if he is able to reach to the end of the array from this position, then we will be returning true. Okay, so let's say okay, so let's say he is at position 3. Now we will recursively call this can reach function, and we will see if from this position is he able to reach to the end of the array, that is at position 17. If yes, so we will return true. Okay, and we definitely have to give some base case here, which we have missed out. So that is, if position equals to stones dot length minus 1, then we will return true. Okay, okay, now can reach, if index is greater than 0, and can reach stones. Now the next position will be next pose, and k will be here k minus 1. Okay, because we have taken k minus 1 jumps, so the next jump, or which from which we have to consider, is k minus 1. So if this is true, then we will return true. Okay, if not, then we will be exploring the other possibilities. So now my next position will be position plus k. We will be taking k jumps. So now the index would be search stones. Then there is next pose will be my next position. Okay, it will be my target position. Then comes pose, low will be my pose plus 1, and high will be stones dot length minus 1. Okay, again I will see if index is greater than 0, and can reach stones. Next position, or k, if we can reach from the kth jump from this current position, then we will return true. Okay, so till now we have considered k minus 1 as well as k jumps. So now let's do the remaining part. That will we will consider position plus k plus 1 jumps. Index equals to search of stones. Next pose plus 1, and stones dot length minus 1. Okay, so now again we will check index is greater than 0, and can reach stones. Next position, and k plus 1. If we can reach from k plus 1 jumps, then again we will return true. Otherwise we can see that he is not able to take any jump such that he can reach to the end, so we will return false. Okay, so that's all we can do it right now. So this is the whole solution, and we will just see it once, and then we will be able to run the solution once. Okay, okay. So stones position k. So this is all right. K minus 1. We are exploring here for k minus 1 jump, and okay, and now here we are exploring for kth jump. Okay. Okay, and now we are exploring for k plus 1th jump, and this is for k plus 1th jump. And then we are also having the method of binary search. It will return me the position. Okay, and one thing I missed is that here, okay, so basically we are not checking the index, but we are checking the value at the position, right? We are not checking the index. So basically this would be stones of position. That is, we will be checking the position plus the number of jumps which he has to make, not the particular index. This is one thing I missed. And here also it will be stones of position, and here also it will be stones of position. Okay. Okay, and okay, everything else seems all right. So now let's try and run it. Okay, it is giving me some errors, so let's quickly fix that. Okay, we missed one thing. We also have to add target position here. Okay, we do not have any other errors. So I hope this runs. Let's see. Unreachable statement. Okay, so okay, this is if index is greater than 0 and can reach. Okay, sorry, my bad. I have added this semicolon here. Okay, it went out of bounds. See, okay, I have made a mistake here. So here we are passing index to the position, but here instead of index, I am taking the current position of the stone. Here we should be taking the index of the stone. So I will replace it with index. Everywhere I have to replace it with index. Okay, and here also I will replace it with index. Okay, so now let's try it now. Okay, and now let's try to submit it. Okay, so let's see what happens. Okay, so as I had mentioned before, it will give me time limit exit error because we are covering all the 2 raised to n possibilities. So it will be a very large value, right? So what we will do to reduce the time complexities, we will use memoization. And for memoization, we will take a hash map. We will take a pair of integer, and we will take a boolean value. Okay, so what, as I had explained you before, so here, see here, 8, for 8, it is appearing 2 times in this tree, and we are, every time we see this 8 value, no, we will just check that is the last index, that is, are we able to cross the river from this current stone. So every time we are checking this, so we have to reduce this, right? So for that, also there is one more thing to notice is, here the path for 8 are different. That is, if we have made a jump 2, we will end up going on this 8, or if we have made a jump 3, then also we will end up being at 8. Okay, so one more thing which we have to realize is, it might happen that while we are traversing, let's say there is a very large array, it might happen that for a same number of jump, that is 2, we might we might come at this 8 again, right? So we have to reduce those kind of things. If, like, if here we have already seen jump 2, and at the we are coming at the position 8. So now, if ever in future, if we are taking jump 2 and we are ending up at 8, so at that time we have already computed the value of this path, right, once, that we are not able to reach from 8 to the end of the array. So why should we compute it again? So here we will memorize the result of this particular path to a hash map, and if we see this particular path again, then we will just directly return its value. Okay, so the same thing I am doing up here. I'll take a hash map. The key of this pair will be the current position, that is the index of the stone where I am, and this will be the number of steps I have taken to reach the current position, and this will be the result boolean, that is whether I am able to reach or not. Okay, so okay, so this is the key, and now I am checking whether, if map dot contains key, if this if map has already if we have already computed this particular possibility, then we will just directly return it. We'll just directly get from map, and we will return it. Else we have to put the output of, like, the answer of the previously computed value to the map, right? That is, like, if we are returning true from this can reach, that is for every answer we are returning, no, from this reach, we will just store it in the map. So here we are returning true, so I will put true in the map. Same case goes for here, and same case will go here because we are returning true here. Okay, so, and same thing will be going on here as well. Okay, and same thing here, we are returning false. So at the end I will just return false. Okay, you can also take a boolean variable, like you can have some if and else statements, and if the result of can reach is true, you can store it in the in some output variable, and you can return it from here, so that you can only have one place to put it in the map. Okay, but I'm doing it like this. So this will be the final solution. We are putting the resultant value of any particular combination to the map, and if we are seeing that particular combination in map already, then we'll just return it. Let me just try to run it. Okay, now let's try for this test case. Okay, where we are making the mistake, what is the key? It is position and number of jumps. So if map contains, okay, let's see if we are putting it everywhere not or not. Here also we are putting, here also we are putting, here also we are putting, and finally we are putting false. Okay, so this is for the current position, and this is the number of jumps. If map dot contains key, okay, we have to return it here. So we have to return this value here, and now let's try and run this. Okay, it worked. Now let me just try to submit it. Okay, great. So this is the whole solution. I hope you are able to get along with this solution, and do comment out in the comment section if you have any doubts, and hope you like and subscribe this video. So bye, have a great day.